Hi everyone, welcome back to AMS Automotive Evolution with me, Christopher Ludwig. So glad you can join us for this session looking at the future of battery technology and the impacts it'll have on manufacturing. We've been talking a lot today about battery, about capacities, about rising input costs, about localization, and in some cases as well about the changing technology, role of production in maintaining quality, and ultimately what that will mean for the industry. But in this session, we have a chance to go in more detail, both on some of the capacity and cost issues that clearly risen to the fore here in the battery supply chain and production, and also understanding a bit more about how changing technology will impact on production. We heard right in the opening or towards the opening of the day from Polestar's Dennis Nobelius about how the expectation for battery chemistry to change every 2 years will certainly put a lot of pressure on production to keep up. And it's exactly that pace that we know we're dealing with in a new way in the automotive industry. Who will win in this change? What business models will emerge, either in terms of how battery cell OEMs and tier suppliers work together, or indeed the sorts of partnerships that we see across the industry, as well as in managing battery range, and how OEMs compete using the battery. All of these are the sorts of things we're looking forward to discuss in more detail with two fantastic experts who I'm happy to welcome here today. I'll introduce both of them before we have a couple of short presentations from each and some room for Q&A. The first expert I'd like to introduce is recently joined Airbus to lead up the disruptive research and technology, and has worked in the battery sector now for a while, including before that, leading battery strategy for a major tier one. He is recently, we've had such a pleasure in engaging with him recently on a number of our channels and articles. One of really the leading experts in this field, Greg Ombach, who's Senior Vice President at Airbus Group. Airbus, so good to have you with us, Greg, and a great chance to learn more again about changing battery technology, your perspective. Thanks again for joining us.
Thank you very much, Chris, for a kind introduction. Hi, everybody.
Great. And before we hear a bit more from Greg on some of his slides, I'd also like to introduce you all to our other panelists, Francisco Carranza, who's the Vice President, Sales and Marketing at Automotive Cells Company, ACC. ACC, of course, is now an important European-based player with investment and ownership across Stellantis, Total, and Mercedes-Benz. So really exciting company with plans, and Francisco is leading on the sales and marketing side. And I think, Francisco, you're a converter, right? I mean, you were previously in the diesel technology, and now you've come over to the light side of the battery industry and helping to lead the next generation. So very excited that we could have you here and learn more about ACC and how you see things developing over the coming years.
Perfect. Thank you, Chris, for having me. This is always a pleasure.
Absolutely. So again, I'm going to hand over to Greg first. Greg is going to take us through some slides and talk about the landscape ahead. We'll do the same with Francisco, and then we have plenty of time for questions at the end. So without further ado, I'm going to hand over this to you now, Greg.
Thank you very much, Chris. Hi, everybody. It's really the pleasure being again we're talking about the batteries and where the future of the battery systems is going to be. And recently I joined Airbus because also in aviation industry is the tremendous change towards more sustainable aviation, and electrification is definitely the part of this as well. Beforehand, I had more than 20 years in automotive industry, and during my recent assignment, I work on the new battery technologies, like for example for Porsche Taycan 800-volt system, which we brought into the production at Tier 1, which was developing that one. And now, if we look on what's happening over the last years, the electrification, it is not new subject to the automotive. Yeah, we had already the first electric cars, which were more than 140 years ago already on the streets, and then we had a long break till now where we're really pushing up the electrification to the higher level. Now, if we look on the typical S-curve of adoption for various technologies, and here I put on the right-hand side of the slide a couple of the technologies which were introducing to the market a couple of years back, and like, for example, TV entered to the market and just reached the almost full penetration during something like 20, 30 years. Compared to the other technologies, it's taking a little bit more longer. Therefore, if we look on the electric vehicles, where we start working on this already 140 years ago, but really till now, the power electronics was not there, the battery readiness was not there, and also from infrastructure perspective and also from the sustainability perspective, we were not ready on going on this path. But now everything changed. Now we are doing this with very high speed. We are on the average penetration of about 10%. And then the question is how fast we are going to reach higher rates. Based on the current data, and we can discuss it later, something like about 10 years from now, we go from about 10% penetration to about 30% penetration of the market. And this means that the three factors have to play very well together. On the one side, the market, it means how we are going to develop it from the product perspective, it means the vehicle perspective, but also infrastructure. Of course, the policies are going to be important in order to support this very fast growth. And very much important technology. And today we are going to talk about the batteries, where we are now and where we are going into the future, and what impact it has from the technology perspective, this journey towards penetration of 100% in the coming years in the future. Let's go to the next one. Now, if we look on the trends and especially the challenges from today's perspective, and we compare it with the challenges which we had a couple of years back, then definitely there is the one major challenge. We're still addressing battery range. Then, of course, it's not enough places to charge. It means infrastructure. Then, of course, the cars are significantly higher from the cost perspective compared to the combustion vehicles. And of course, you know, the charging easiness is still not there. Therefore, if we're going to change and we are going to look how the battery system should look like, then definitely we are talking about the battery capacity. You are talking about the super fast charging capabilities, like, for example, first 800-volt battery system introduced by Porsche and this technology into the market with very high speed charging rates, like 350 kilowatts, and they are already some charging rates even going beyond this. Of course, the cost plays a role, the safety and the lifespan, in order to reduce the cost of or increase the life of the vehicle at the end of the day. And building blocks, energy density, second life, and diagnostic are the key aspects which have to be addressed already today in the future battery systems. Now, if we look from today's perspective on the value chain, it means from the raw material to the battery manufacturing and the car manufacturing and the second life, if possible, or even recycling, then there is the value chain which goes from the raw materials, from the cells, build up the cells, modules, module assembly, pack assembly, and then second life, and of course the vehicle assembly, second life, and then battery recycling. And here today, we had a couple of the actors. On the one hand side, on the left-hand side, we have the cell suppliers, which had the competence in this, like CATLs, like Lishens, like LGs, Samsungs, and so on. Then on the right-hand side, with the car manufacturers, which are taking up those batteries and putting them on the cars. And in the middle, we had the tier 1 suppliers, or tier 2, tier 1s, or tier 3s, tier 2s, and tier 1s. But the role of the tier 1 was to merge those two worlds. It means to make the connection between the cell supplier, which had no experience in automotive till now, and or at least not as much, and then OEM, which had not as much experience in doing the cell manufacturing and doing such kind of the integration. And here, definitely, there was the huge role where the tier 1 had about 10-15% of the value chain in the percentage on this entire end-to-end value chain. Now, if we look into the next phase, it means, go to the next slide, please. If we look now to this, what is happening in the auto industry, then we definitely see tremendous change in this business model. It means going from this horizontal business model, which I was talking about, going more to the vertical integration business model. And this is very similar to this, what of course the Tesla is doing or the BYD is doing, and the other car manufacturers are following this business model. And there are a couple of the reasons for this. One of them is, of course, that their battery system in the vehicle has a big part of the entire value. On the other hand, also securing the entire supply chain and controlling the supply chain requires a lot of know-how from car manufacturers, which have to build up this know-how from ground up in order to address it. And with this, what we see that the car manufacturers are going down the stream, almost to the raw material, and doing a lot of the investigations and development and the research in order to develop next generations of battery systems. On the other hand, the cell suppliers are trying to go up the stream and doing more than just cells, understanding better how the cells is going to behave in the vehicle, what kind of data we can collect, and how we can bring it back. And here a good example, for example, CATL, which presented how to make variable pack and doing the standardization on the spec and in order to supply it to the various car manufacturers. Now, with this, the tier one, which was this interface between left and right side, is going to lose. It's going to lose because automatically the value which can provide is less, because car manufacturers can cover more and more this value chain downstream, and the cell suppliers, on the other hand, will go up. Who is going to win at the end of the day? I think there's going to be some equilibrium, and we are going to see a lot of still dynamics in this terms. And especially this is going to be also supported by more integration into the car, like going from the cell module to the cell to pack, and also to cell to chassis. Therefore, this requires being closer to the chassis than just thinking about the cell by itself. Now, from that perspective, there are a couple of the trends which we see in the industry. And of course, the one is the more forward integration system and cell design, how we are going to build it into the pack. It means it's going to be reduced numbers of the mechanical components in order to reduce the cost and make the battery pack more simpler. And also having in the thought about the second life, having in the thought about remanufacturing. It means how we are going to repair the system if some cells are not performing anymore. And of course, thinking also about the recycling. It means how to make the design for recycling, which is very important. Also, what is very important is the thinking about the processes, how we can simplify the entire process chain in order to make the cells and then integrate them into the packs. And here a good example is, for example, going for the dry coating process in building up the anodes and cathodes. And here was also the reason why the Tesla a couple of years back acquired the Maxwell. It was not about the super caps, it was really about the dry coating process in order to reduce the energy and the time consumption during the electrode manufacturing. And this is going to be seen more and more. And there are a couple of the innovative startups in that area which are developing this technology, and we are going to see this very soon also into the market. And then, of course, chemistry. A lot of the changes, and honestly speaking, by working on the battery systems for a couple of years, every few months you get the next generation of the chemistry, or we had it. Therefore, with this, automatically you could do upgrade of the battery system on the vehicle almost every 2 years and bring up additional value to the end customer in form of more range for the same amount of money. Therefore, here are a lot of changes, and this means if there are so many changes, then you could just drive them if you are really vertically integrated in order to have a control of the value chain. Now, from the chemistry perspective, we see definitely that there are some changes going on. It means, of course, the all type of the NCM cells which we have today on the cars, but we are going to the downstream, like the LFPs, lithium iron phosphor, in order to address on the one side, the cost, on the other hand, also the safety aspects. And here, even there is the next generation coming, like the sodium batteries, which maybe from the energy density are not as perfect, but still they're from the material and price and the safety aspects are very good. Therefore, probably on this low end on the vehicles, once we are going to be on something like just city vehicles, the small A-level vehicle, then or AB class, then probably this type of the chemistry is going to be good enough. On other hand, if we think about really the safety and higher range, then everything what is happening around the solid state is everywhere to be looked after. And here we have also a couple of the interesting companies which are bringing the technology already to the small volume production. And definitely during the next 3, 4, 5 years, we are going to see more coming from this end. And now, if we look to the real future, something like 10, 15 years ahead, then we are going to see also the sulfur batteries, which are really the game changer and completely going to change the e-mobility, not just on the ground, but also in the air. Now, if we think about the solid state, and I talked a little bit about the simplification of the processes, then this is definitely the game changer because it's going to definitely simplify the entire cell production process of about 40% because we are removing all parts about the electrolyte, the liquid electrolyte. And also we are going to simplify integration of the cell into the pack because the cell can be suddenly much bigger and we can think about completely new designs and new cooling concepts, which are going to come with this new technology. And also the cycle time is going to improve, therefore about 200% per production line. This would mean from the same amount of the capex, I can produce much more. If we think about the next generation technologies, and here, if we're talking about the solid state, then on the left-hand side, you can see what is the volume production today for the traditional batteries or lithium-ion batteries, where we have, of course, a lot of the players from Asia, like CATL, BYD, Panasonic, LG, Samsung. They are the top tiers in production of the batteries. Now, if we would look what is going to happen in the future, and we talk a little bit about the solid state, and we look how much patent protection is already in the place for the next generation of the technologies, then we are going to figure out here on the right-hand side, you can see the picture about the IPs. It means also Asia is leading on the new technology developments, of course, with Japan, with Korea and China. And unfortunately in Europe, we are still, or in North America, we are still lagging this kind of the developments. We are doing a lot, but still compared to this, what already happened, we are far away. Therefore, we have to put a lot of the effort in order to catch up and really provide additional value. With this, guys, I would like to thank you very much for this short for having opportunity giving you this short presentation. And now we are going to talk later on now to the next presentation from Francisco. Thank you.
Fantastic, great. Thanks so much, Greg. As always, fascinating look into the changing technologies that we see. And I think you really painted a great picture of the relevance for our audience here. But as you said, I'm keen now to bring Francisco on so that we can hear more from ACC's perspective. So we're going to bring Francisco, and we have a short presentation here as well before we go to some Q&A. So I'm going to hand it over to you, Francisco.
Fantastic. Thank you, Chris. Let's see if the slides are coming. But before you can see anything there, so quickly, as you say, I've been working in the car industry now for more than 20 years. Most of those years working already in electric cars. I joined Nissan when we were launching the Nissan Leaf back in 2010. So I've been experiencing how difficult it is, this switch from combustion engines to electric for many years now. So in the next slide, what you will see is because of the regulatory framework and all the push that the society has been putting in this industry, essentially every car company has decided to go to the full electric technology. So it's There is no more doubt, there is no more debate. At some point of time, many years ago, I remember we were talking about biofuels, hydrogen, and hybrids, and I think this is now clear. Everybody's going full electric. Different timing depending on your market and the type of vehicles you have, but it is clear that at least in Europe, we're going to be hitting the 70% market share of the full electric cars by the end of the decade, and which brings a certain number of challenges. And one of the most important is how competitive this product will be. Many of you will remember at the beginning we were talking about the early electric vehicles. People were talking about, okay, how far I can go, what is the autonomy range, how fast I can charge. So autonomy range is now relatively under control. You see electric cars already hitting the 700 kilometers range. Fast charging, same thing. So many models out there are already close to 15, 20 minutes for the 10 to 80% charge. So the technical problems are essentially being solved, most of them. But we remain, we still have the key challenge on how competitive this product will be. And from not only from the total cost of ownership, the TCO, but also from the tag price, which is the key factor driving most of the sales. So in the next slide, you will see a few examples that I took a couple of weeks ago. Apologies from the French market, that was the easier way to get some data for me at that time. But it gives you an idea of what is the difference of the retail price between a model that has a combustion engine and the equivalent model having an electric powertrain. So they are really comparable cars. You see that they come the same version, the same type of equipment, and at the end, what the end customer is seeing is that if you buy the electric version of the car you like, you're going to pay between 8,000 to 11,000 euro more for essentially the same car, but being just electric. All of this, with all the efforts and all the cost decrease that has been achieved in the batteries, in the electric powertrain in general, is showing that the parity at the top price is not there yet. And we still have a lot of difficulties in seeing how at some point of time in the near future this could be achieved, which is leading to a major question mark, right? So if the electric vehicles are more expensive than the combustion equivalent, how realistic is that 70, 80, 90, 100% of the market will be electric? It means people will need to pay more for mobility, and they might have some people in the middle class that simply don't have the money to buy an electric car anymore because of the premium they have to pay because it is electric. So one of the key reasons why we have that gap is the fact that there's a number of materials that are required to build a battery that are very expensive. And here I'm showing you a few examples. Essentially, I took a random 100 kilowatt hour battery with the latest technology. So it's nickel manganese cobalt 811. So it's the most recent technology you see out there. And how much it was the cost of the three main materials of the lithium, nickel, and cobalt a year ago versus where the cost is essentially right now. So I took the prices for last week, and you see a tremendous gap. So just the raw materials, so the powders that are putting in your battery, and from the three key elements, so as I say, nickel, lithium, and cobalt, is already $2,500 a year ago, and is hitting more than $7,000 at the moment. So in that context, it's very difficult to keep challenging in terms of the cost parity, because you see that even in the material side, it is very hard to keep it under control. So obviously, you will see all over the media, car companies now looking at investing in the mining area, in the material refining area, trying to find additional sources or secure a portion of the supply of nickel in Indonesia or lithium in South America, or even here in Europe, trying to see if we can mine lithium in places where car companies will feel comfortable, because it's somewhere in Western economies. But all over at the end, in the short term, it's very hard to see how we're going to get closer to the cost parity between the combustion engine vehicle and the electric one. As I said before, it's a big challenge in the sense that we don't want the market to shrink, and we want to make sure that all our customers have the enough purchasing power to afford mobility in the future. And that's it on my side. More than happy now to go to the Q&A.
Okay, thank you so much, Francisco. And pretty sobering stats that we're looking at right there that we just saw in those slides in terms of the cost of the battery. And I want to bring Greg back in as well here for the discussion. We've got about 20 minutes or so that we can go through some key topics. I want to kind of start actually on those supply chain costs that you just highlighted there. And clearly there's risks there. It's hard not to see those sort of risks kind of staring right at us. So from a perspective of ACC and I suppose your partners and customers, what do you see as the key areas to really mitigate that? You raise things like mining and other things. Maybe more long term. Are there kind of short and medium term things that you can be doing to mitigate that?
Yeah, I think there are not miracles. At the end, there are not many things you can do. So the first one, obviously, is try to secure long-term offtake agreements. Try to reassure your suppliers that you have a long-term commitment as an attempt to secure a certain amount of raw materials and secure, let's say, a cost that is coming with a certain discount versus the market. So this is like the basic deal that we all need to do. Now going forward has become more important because the price keep getting up and up and up. So it is critical that we start looking at how much vertical integration could be part of the overall strategy.
So vertical integration, a key part of that. Greg, do you see this accelerating some of the mix that you pointed to? I mean, some of those technologies, some of them are, as you pointed out, 10, 15 years away, but nonetheless, are we seeing acceleration in some of those other mixes to try to mitigate that?
Oh, definitely. It is what we see, for example, on the sodium side. It's coming back now again, almost into production, and we see that from this lower end, we are getting more and more solutions, which are, I would say, more resilient if we are talking about the dependencies on the material side, and here there are definitely the short, medium, and long-term solutions. Of course, the long-term solution is going to, or some additional materials will come back from recycling. But if you are just thinking about the short and medium, the short is already now. Therefore, we have to unfortunately live with these shortages on the material side. But the medium is addressing especially the next generations, where we try to reduce the amount of the more difficult components from material perspective, but also with this thinking about the more clever designs. And also doing some new solutions. It is what I just mentioned in my presentation, where the CATL presented the variable pack, where you could add some additional modules if you need it once we are going on the highway or on the longer journey. Therefore, I think that there is going to be mix for time being, and with this, once we will move also to the solid state, automatically from the same material we can gain more, and then automatically we will be able, I would say, to cover these challenges with the newer designs and newer technologies.
Francesco, is that part of how ACC is looking to adapt as well? I mean, you're obviously in a ramp-up phase to build several gigafactories. I imagine you're still, in a way, developing product and technology and perhaps adapting it as you need to here. So is all these factors coming to the fore here?
Yeah, indeed, as Greg was saying, that there are a few things that need to happen. First, that we need to optimize the overall design of the pack, essentially having the same amount of kilowatt hours in a smaller space in the vehicle, try to remove as many components as possible to keep the cost down, while at the same time increasing the diversity in terms of materials, right? So reducing the pressure on a specific component because you have alternatives to put on the market. So this is clearly the way forward, but it's essentially midterm plan.
We've had a couple of audience questions go in, and I actually want to turn to them since I think they're quite relevant. One from David Threlfall, who's actually at British Volt and is joining us to speak in 2 days. And David's question is for you, Francisco. Do you think cost parity going forward may be skewed or affected by potential car as a service rather than leasing a vehicle, which can explode EV adoption? So the example he gave was Rolls-Royce no longer selling aircraft engines, they charge per mile. So stepping back, I guess the question is really the business model. Will the business model of electromobility shift or change to kind of partly address this issue? I think maybe I start with you, Francisco, there, and obviously Greg, if you have comments on that, interested to hear them as well.
Yeah, absolutely. Clearly, if we see no cost parity coming anytime soon, we need to find additional ways or different business schemes to allow our customers to afford electric mobility. So it is something that was started by Renault very early in the process, as many of you might remember the battery lease scheme, and they are trying to do now with the Mobilize brand, where the goal is really moving from the traditional vehicle purchase into a full service where you just pay a monthly fee and you get your car, the insurance, the energy, anything you need for mobility into a single monthly fee. It is very clever, and I think is a way forward.
Greg, would you add anything to that?
Yeah, definitely. I think that also this kind of the models are going to help. I don't think that they are going to solve the challenge which we have, because the gap is too big. Therefore, if you think about the sharing economy, which we were very into before the pandemic, then this was already growing very fast. Now, because of the pandemic, it's already reduced a little bit, and then automatically we are start thinking about other business models here. Now, at the same time, it's not just about introducing new business model and hoping that it is going to solve the problem. This can offset it only. We have still the challenge where making the electric vehicle is more expensive, and it's not just about the vehicle. Even if we would be able to make the vehicles today on the cost parity, we would have the infrastructure challenge. Because as I mentioned already at the beginning, we are just the beginning on the adoption curve. Therefore, if we are going to move from this 10% to 20 or 30% on average, then automatically we have to also invest a lot in infrastructure, which has to happen, because not everybody has the access to the charging point at home and or the charging wall box, and the people have to charge. Then once we are moving up on the S-curve, they have to charge in the public, which is going to be as big challenge as the materials are, because it is very, very expensive as well to install the infrastructure. And then the business model behind, if you are going to charge too much for electricity, then suddenly we are going to have another challenge, which means it's not just the battery cost, but the total cost of ownership is not going to be less.
It's great points. There's another audience question, which I'll bring right up, and the question it's addressed to Greg, but I think it can go across either, of course. Are you seeing examples of battery manufacturers designing battery enclosures for the OEMs, whether specifically in North America or Europe? So Greg, to you first, because you talk about this horizontal to vertical changing landscape. Do you see battery manufacturers getting deeper or closer to the enclosures as well?
Definitely, there are a couple of the programs already in the past. I would say the battery enclosure is somehow the part of the vehicle structure. Therefore, the design was coming from car manufacturers. The question was who is producing that one. And if you are thinking about the enclosures, that it was not the tier 1, it was more the tier 2 even, which were looking after an enclosure based on those designs which were coming from OEMs and flowing also from the tier 1 as an integrator to specify some more detailed aspects on the enclosure from the process perspective. Now, there have been a couple of the innovative solutions going even to some molded enclosures and so on. But now with the forward integration, it means taking and going from the module to pack designs, then this is going, or this kind of the enclosures are much more simpler because you are integrating them more and more into the chassis. Therefore, if we just look the enclosures like for example, Tesla has, or the other like BYDs, they are very, very simple from that perspective. There are no more the parts which have to stabilize the entire vehicle structure. Therefore, from that end, the design is going to remain with the car manufacturer more and more. And then, of course, the supply chain, mostly tier 1s and tier 2s or tier 3s even, are going to produce them and deliver them straight to the car manufacturer, no more to the tier 1.
It's an interesting shift. Francesco, obviously, are you at ACC? Are you working on these sorts of concepts, designs together with your OEM partners, co-owners, however we want to phrase that, or is it a kind of clear separation in terms of obviously cell versus the enclosure design?
Well, as Greg was saying, the future cells are going to be more and more let's say, closely integrated into the vehicle platform. So it's not something you can do on your own. So you need a strong cooperation between the car company and the cell maker to make sure that by combining both expertise, let's say you get into an elegant and efficient solution from the cost and the performance point of view. So it is no longer just a battery pack that you can put in a car and then another one. So everything will be really tailor-made to a specific platform.
Absolutely, and you know, again, from your point of view, what Greg was talking about, obviously the changing cell designs, and so is this still quite a changing picture for ACC? Are you looking at a multiple designs, or are you more focused in on cylindrical, pouch, etc.? Just from where your perspective is today.
No, for the moment, our focus is essentially on the hard prismatic. Because it's the one that has the easier integration in the platforms of our customers. So we are really sticking to that one. That is also the one naturally fitting the best into a cell to chassis and cell to underbody structure because of the nature of the hard case prismatic.
Okay, yeah. So this will ultimately support the cell to chassis integration.
Exactly, because of the mechanical properties of the hard case.
Absolutely. Going back a bit to some of the cost issues that you raised, the CEO of ACC, Jan Vincent, recently did say that those costs, material prices in Europe could drop once more mining was established. Again, this is not an overnight venture. There are partnerships that are starting to form, but from both of your point of view, starting with you, Francisco, what sort of timeline do you expect for this to reasonably really, you know, emerge as a value chain in Europe?
It's certainly going to take a long time because, you know, the lead times in the mining sector are not particularly short. So it is fundamental at some point of time, you know, the offer meets the demand. But our expectation is it's not going to happen anywhere in the near term. So clearly, by the end of the decade, we all hope that the offer will be already enough to get the demand satisfied.
And Greg, you know, we were actually recently together, and we were talking about, you were sharing with us insights in North America, for example, and rural Canada could play as a center, not just of cell, but really of further upstream sides. Do you see some equivalent in Europe? Do you see some opportunities that could develop more regionally in Europe?
Definitely there is some opportunities here, but if you compare us to the Canada particularly, then of course we don't have as many opportunities if we are thinking about the raw materials and putting the mining in place. Therefore, this is already reduced. Therefore, definitely there are the places where we could win some lithium, but still the other materials probably we have to import in order to make our batteries. Therefore, I think it's going to be about I would say desertification of the supply chain. On the one hand, okay, we still rely on this, what is happening and coming from Asia. On the other hand, this new stuff which is happening in North America definitely is going to offset and help and support with the entire challenge which we have. And I fully agree with Francisco. It's not a question if we can do it. It's just a question of time, because there's enough material available. And then if the mining industry is going to build up their capacity over the next few years, then the demand is going to be, and of course this what we can produce is going to be already on the level where we can balance this, and especially also with the technology developments which are coming, assuming in a couple of years from now we have really the solid state, which from the same materials we can reach something like 20, 30, 40% more energy density. It means more range, or we are going to make it smaller, and also we are going to start integrating and building up the more cheaper electric vehicles with the shorter range, what already Tesla is doing with LFPs, and already other cell suppliers and car manufacturers are looking after the sodium material in order to entry to market vehicles, I would say, bring into the market to balance this on the material side. Therefore, and the cost, of course. Therefore, the de-risking is going to happen by looking after the different places, what is currently happening, and of course, building up and opening the mines takes a couple of years in order to be able to deliver materials. Therefore, it's going to be mixed combination, and this is what also Francisco was talking about, more clever integrations to the vehicles in order to reduce weight. And maybe we are going to shift also away from having all electric vehicles, only SUVs, in order to think also about energy consumption. Because if you look how many kilowatt hours per 100 kilometers the car is consuming, then we as a users, we will start understanding that it is not only just putting bigger and bigger batteries on the car, it's also about making the cars more efficient. And this would mean thinking about from efficiency perspective, like we are buying today the fridge. We have the classes on the fridge like A++, how many kilowatt hours per year the fridge is using, but with the education and understanding from the customers about the aspects about the energy consumption, because it's that game changer. Once again, we have to the people always were talking how many liters fuel per 100 kilometers the car is consuming. Now we will start talking about kilowatt hours, and this is a mind shift which we have to go for. And with this we will address this, I think, in the proper way, and they are solutions, and I'm sure from the technology, from the product, but also from the business model perspective, we will solve the challenges which we have today.
Very important points. We're coming close to the end, but I maybe just want to hold you both for a question or two more. Francisco, on the recycling side, obviously, again, you're still in the in the development and ramp up phase. What sort of role and mix will recycled materials play in the early part of your ramp up, and how will that evolve, let's say, by 2030?
Well, unfortunately, not much in the coming years, because simply there are not enough end-of-life batteries available to be recycled, right? Which is normal in the sense that we know that the useful life of an electric car is very long, and certainly we're going to start seeing some volume of end-of-life vehicles coming to recycling by the end of the decade, but I don't see how at the end we can get above the 4% recycling material by 2030, simply because there is not enough supply of end-of-life batteries.
Mm-hmm. Yeah, thank you. Very fair point. And Greg, obviously you have a career spanning in the automotive industry or expert on these areas, but you're now also working for Airbus. And so some watching might be wondering, okay, well, how important, what role for batteries will we see in the air mobility, aerospace, or perhaps even air urban mobility, different aspects? Can you give us a hint, at least, of what you're thinking and what you're looking at, and some aspect of when we might see electrification start to move more into the aerospace sector?
Chris, it's a great question, and it's also the reason why I decided, after 20 years being in automotive, going to the third dimension and helping changing this industry as well in the direction which automotive is already doing over the last couple of years. And definitely, we are going to see more and more various electrifications coming on the board of the various planes. Of course, it's much more easy to start with something which is smaller. And honestly speaking, there are a lot of the similarities as I see between both industries. Of course, the challenges you have if you think about the plane is that it is not just about energy density. It's also about the entire range about the entire weight and safety. The safety is always the number one concern. And I just give you an example. If you think about the cars and you have thermal propagation test, it means in case if you have some failure in the battery and the one cell is going to have a problem, and then you have to provide based on the GB standard, with the Chinese standard, and we have to prove it in Europe if you would like to sell the cars in China, for example, that about 5 minutes time there should be no fire in the cabin. Now, such kind of a test is much more harder on the aviation, because you cannot imagine that you are just giving 5 minutes to the people suddenly to land somewhere, therefore, or to the pilot to land. Therefore, only from that perspective, it's a really dramatical requirement on the safety. And this is also the barrier how easily you can bring these new technologies to the third dimension. Therefore, looking after the solutions which are going to be more safer, from that perspective, we think about the batteries. It means the entire solid state path definitely is going to help and support, but it is still quite far away. We are going to see penetration of electrification going in the phases, starting with the smaller, like the urban air mobility, and going to the bigger planes as a full electric or the hybrid solutions, or of course the combination with hydrogen, which is also the solution for such kind of electrified concepts.
Well, exciting, and what a fascinating landscape. Great that you can apply experience from automotive mixed into this. We're very happy that we can share some of that with our audience. Maybe just for time for this one last parting question, Francesco. We're here in 2030. Let's say, hopefully some of the crises that we've been facing today and this year are behind us. But I can't know if anyone can guarantee anything. But what would have been the most radical change in battery supply chain and production that will really have helped and support to optimize this? What do you hope to have seen by then?
Well, clearly we need a breakthrough in terms of technology. Greg was mentioning about the solid state. We need to find a solution that is, from the technical point of view, is gonna step up the game here. Is gonna allow the industry to go to the market with a product customers can afford, and a product that has no compromise in terms of autonomy range, in terms of recharging capabilities. If we are really heading towards 100% of the market being electric, we always need to keep in mind the customer needs, because it's at the end the person that is going to pay for the product you are developing.
Fantastic, Greg. Anything else you want to add for your wish list for 2030?
Oh, I would have a very long list, but if I would just think about a couple of the things, then definitely from the supply chain is diversification. It means we are going to have already much more, I would say, options in the 2030 than we have now. It's a one end, then especially Europe, but also North America, in order to have I would say something to balance the Asia particularly. It will be on the material. On the other hand, of course, the technology developments. And here we have to talk really about very aggressive, from European perspective and North America perspective, to aggressive developments here, because today still we see a lot of the things coming from the Asian side, and we should also balance this one. Therefore, I'm looking into that direction too. And of course, the entire game between the car manufacturers and supply chain, it is incredible interesting, because suddenly you have the new players on the block, I would call this, like the cell suppliers, which had no experience in automotive. On other hand, they are very powerful. If you just look at the CATL, Samsungs, LGs, they are huge powerhouses. Therefore, there's very interesting the power game happening now in the supply chain. And then I would love to see some, I would say, balance also in 10 years from now, to see that we are collaborating together and not just pushing from top down, but there is going to be bidirectional communication in order to develop the best for the customers.
Fantastic. That's a future that I'm looking forward to, that I'd be excited to be a part of. And I really look forward to watching it form and continuing to exchange with both of you and your companies and with our audience further. So a big thank you to both of our experts today, Greg Ombach from Airbus and Francisco Carranza from ACC. It's been a pleasure to host you here. Thank you so much for your time.
Thank you very much, Christoph. Thanks, Francisco. And thanks, everybody who was watching us.
Absolutely.
Thank you, everybody.
Thanks so much. Yeah, and to our audience, as usual, thanks for your questions and your input. We'll be back here in just under 10 minutes with a keynote presentation and interview with a startup called Automotive and their COO, Just Tech, who's recently joined from Tesla. So it's not another one you won't want to miss. Thanks again, guys. We'll see you real soon.